Honors Geometry, Note Section 10.3, Law of Cosines. Well, we just finished up law of sines. Law of sines you can use in any triangle as long as you know the measure of an angle and the length of the opposite side. Law of cosines can be used when you don't have that combination. Law of cosines. Let triangle ABC be any triangle with sides A, B, and C representing the measures of sides, opposite angles A, B, and C respectively. So same kind of triangle that we drew before for law of sines. Angles are capital printed letters. Sides opposite those are lowercase printed letters. Well, according to the law of cosines, each of these equations have to be true. Let's focus right now just on this bottom one. You recognize this? C squared equals A squared plus B squared. That's the Pythagorean theorem, assuming A and B are legs and C is the hypotenuse. So if you can remember that, it's kind of like the Pythagorean theorem. Then it's minus 2 times this letter that's on the right side times the other letter that's on the right side. And it's cosine of the angle, and that angle is opposite of the same letter, C, that was over on the left. This needs memorized. This pattern that you see here is the same for each of these. Starts out with a letter, that letter is not used again, but the uppercase version is the angle. The other two letters are squared and added together, and then you're subtracting 2 times those, and then times cosine. So needs memorized, whatever it takes to get that done. When can you use law of cosines? Once again, I don't know how these numbers end up becoming 3s and 4s. My apologies. You can use law of cosines to find the measure of the third side of a triangle if you're given 2 sides in the included angle. So here's a scenario. If you're given 2 sides in the included angle, or to find the measure of an angle of a triangle if the measures of 3 sides are given. So let's say that we're given these sides, and you want to find any of the angles, such as this. Let's just not say that. You're given 3 sides, and you want to find any angle, you can use law of cosines. I just remember it as I can use law of cosines whenever law of sines doesn't work. Now this last thing is important. If you're given side, 3 sides, you can't use sines to find the largest angle. And that's because the ambiguous case of sines might come up in that situation. Well, I guess that's not true. Here's why you can't use law of sines to find the biggest angle. If the biggest angle is, let's say, 150 degrees, and you use your calculator and you do sine inverse, it's going to give you an angle of 30 degrees. Your calculator will never give you an obtuse angle when you're using sine. It just won't. Long story short, if you're given 3 sides of a triangle, find the biggest angle first using law of cosines. That's the bottom line. Let's check out an example. Given triangle ABC, so let's label the angles A, B, and C. Sides opposite those letters are the same but lowercase. Lil a is 20. Lil c is 24. Measure of angle B is 47 degrees. Now when you're doing your homework for this, don't assume you're going to use law of cosines. We've learned law of sines as well. You have to assess each problem and see which thing you're going to use. Do we have an angle and the measure of the side opposite of it? The answer is no. So we can't use law of cosines. I'm sorry, we can't use law of sines, so we must be able to use law of cosines. So I would start with the angle that we're using or the angle we're trying to find, which is 47. Let's measure angle B. So the law of cosines equation we're going to use is going to be little b squared equals a squared plus c squared minus 2ac times cosine of the measure of angle B. Every time you use law of cosines, you must write this equation out first, and then start plugging stuff in. We don't know what B is. We know A is 20. We know C is 24. We know A is 20. We know C is 24. Whoops, I left off cosine. We know the measure of angle B is 47. Excuse me. Pardon me. Before we continue, let's discuss how many terms are there in this equation. There's 1, 2, 3, 4. This monster right here is all one term. Now, why is that relevant? Let me show you why. 20 squared is 400. 24 squared is 576. I used a calculator for that. 2 times 20 times 24 is 960. I also used a calculator for that. Now, I'm not going to type in cosine of 47 into my calculator yet because I don't want to round until I have to. At this point, there's still 4 terms. 1, 2, 3, 4. I can combine 400 and 576 and get 976. A rookie mistake on this. The students try to subtract those two numbers. You can't. This is not a 960. It's a 960 cosine of 47. There are 2 terms on the right side of the equation right now. They are not like terms. One has a cosine of 47, the other one does not. To get b by itself, you're going to square root both sides. Anytime you initiate a square root, it's plus or minus. We're trying to find the length of b, which is in a triangle. For our purposes, those are always going to be positive. Put this in your calculator. You're going to get about 17.9, positive version. Directions, find the length of b. We did it. Let's do another. In triangle ABC, let's draw that little fella. Little a is b. Little b is c. Is 6, I should say. Little c is 7. Excuse me. Find the measure of angle C. Since we're trying to find the measure of angle C, well, first of all, let's ask ourselves, are we going to use law of sines or cosines? To use sines, you have to have an angle and the side opposite of it. We don't have that. To use cosine, you just have to be able to not use the law of sines. Since measure of angle C we're trying to find, our equation is going to start with little c. C squared equals a squared plus b squared minus 2ab times cosine of the measure of angle C. We know that C is 7. When you substitute, use parentheses. We know A is, I wrote A as B. That doesn't make sense. It's supposed to be a 6. No, it's supposed to be a 5. My apologies for that. A is 5 and B is 6. So we are trying to get this by itself. Before we do that, we need to get this by itself. Simplifying, 7 squared is 49. 5 squared is 25. 6 squared is 36. 2 times 5 is 10. 10 times 6 is 60. Now once again, how many terms are there? 1, 2, 3, 4. Let's combine these like terms here on the right side of the equation. 25 and 36 is 61. How many terms are there in the equation right now? 1, 2, 3. 2 of those are like terms, the 61 and the 49. The other one is this whole big thing, 60 cosine of measure of angle C, not a like term. I'm going to subtract 61 from both sides and get negative 12 equals, here's another rookie mistake. Once we get rid of that 61, this subtract sign becomes a negative. So it's a negative 60 cosine of the measure of angle C. We have two terms. We are trying to isolate cosine of measure of angle C and then isolate measure of angle C. Let's get rid of the times negative 60. A negative 12 divided by a negative 60 is going to be positive 12 over 60. That reduces, but let's just leave it for now. The right side is cosine of the measure of angle C. How are we going to get measure of angle C by itself? Well, we have to do a cosine inverse to both sides of the equation. On the left, that would be cosine inverse of 12/60. On the right, the cosine and cosine inverse cancel, and you get measure of angle C. I think the direction said round to the nearest whole number for angles. I put this in my calculator, and I got about 78 degrees. Let's try this last problem. George is 20 inches from Riquito and 100 inches from Danny DeVito. The angle formed by the two and George is 30 degrees. How many inches apart are Riquito and Danny DeVito? Well, let's see. We got George. He is 20 inches from Riquito. And George is 100 inches from Danny DeVito. The angle formed by the two and George is 30. That would be this angle here. How many inches apart is Riquito and Danny? We're trying to figure out what little g is. Little j. Law of sines won't work because we don't have a side and the angle opposite of it. So law of cosines must work. We're trying to figure out what g is, so it's g squared equals. Let's go d squared plus r squared, calling this d and this r, minus 2dr times cosine of the measure of angle g. Fill in what we know. We don't know what little g is. We know that d is 20. We know r is 100. We know the measure of angle g is 30 degrees. 20 squared is 400. 100 squared is 10,000. 2 times 20 times 100 is 4,000. Combine these like terms. We get g squared is 10,400. This is all one term over here, and it doesn't have a like term. That's 4,000 cosine of 30 degrees. To get g by itself, the right side is simple, so we can get it without rounding. We square root both sides. We get plus or minus 10,400 minus 4,000 cosine of 30 degrees. Put this in your calculator, and the positive version is about 83 inches. The directions don't say how to round, so we're going to go with 83. 1 decimal place. Riquito and Danny DeVito are about, because I rounded, 83 inches apart. That concludes the notes for law of cosines. Please do your homework. Keep in mind, you could use law of sines or cosines for any problem, depending on the information you're given. Thank you very much.